Hello, today we're going to use square roots to solve quadratic functions. So I just want to remind you of something. When you're solving equations and you take the square root of something, you have two different answers. Like the square root of 16 when solving an equation is both positive 4 and negative 4, because if you do the opposite, 4 squared is 16, and also negative 4 squared is 16. So when you take the square root of 16, both positive and negative square root of 16, you get positive and negative 4. Okay, so today we're going to solve the equations that we've been working with, quadratic functions, but instead of graphing. And we can only do it this way because in standard form we don't have a b. All these equations, we don't have a b value. We have our x squared value, we have our constant value. So for example, the first three that we're going to work with, the first one is 3x squared equals 27. So we're just going to solve it like we've been solving equations, but our last step is to get rid of that square and take the square root. So the first thing to do is to divide by 3, and then I get x squared equals 9. I have to take the positive and negative square root of both of them, and then my answer is both positive 3 and negative 3. I have two answers. So if I were to graph this parabola, my solutions would land at both negative 3 and positive 3, some sort of u that passes through both of those points. But I didn't have to graph it to find it. All right, here's another equation, x squared plus 12 equals 12. So I, again, subtract 12 to eliminate whatever is happening. Then I have x squared equals 0. Take the positive and negative square root, and I get 0. So that means if I were to graph this one, x equaling 0, it means I only land on that point. So some sort of parabola where the vertex is at 0. Another case we have is x squared minus 3 equals negative 4. So I add 3 to both sides and I get x squared equals negative 1. I take the positive and negative square root of both sides, but here's a fun fact. You can't take a square root of a negative. It doesn't exist. The square root of a negative, right? There's no number that I can multiply by itself that I can square and get a negative number, right? Either way, if I multiply negative 1 times negative 1, that's positive 1. 1 times 1, that's 1. Because it's got to be that same number, you're squaring it. All right, so these are all our almost simple cases. You can get two answers, one answer, or no answers for your parabolas, and we knew that. We could either cross at one point, cross at the x-axis at no points, or at 2 points. That's not new. All right, the next one we're going to work on is slightly trickier. You have 4 times the quantity x plus 6 squared minus 7 equals 17. So the first thing we're going to do is add 7 to both sides, and you get 4 times the quantity x plus 6 squared equaling 24. Then you divide by 4 to eliminate that 4 up front, and you have x plus 6 squared equaling 6. Then you have to take the positive and negative square root. This part's tricky. All you have to deal with is that this whole quantity is being squared, so you have to undo a square, take the square root. And now this positive and negative square root of 6, that's also tricky because it's not a perfect square. So you just leave it under the radical. So then I have x plus 6 equaling positive and negative square root of 6. I gotta get x alone, so I'm subtracting 6 to both sides. And I always put that in front so it's not confusing. So x equals negative 6 plus or minus the square root of 6. So if we were going to estimate what the square root of 6 was, say we wanted a more exact answer, this is the most precise answer, but say we want to estimate to graph it or something, you would take the square root of 6. Well, I know it's somewhere in between 2 and 3, closer to 2, probably like 2.4. I'm going to estimate. Did not use the calculator, could be off. And then, so what I'm doing here would be negative 6 plus 2.4, that's around negative 4, negative 3.6 is one solution, and then negative 6 minus 2.4, so my other solution is negative 8.4. So on this coordinate plane, right, those two things, that parabola is somewhere over there on the negative side. All right, cool, we'll practice more.